Entanglement. Explaining entanglement. Particles maintain magnetic relevance to each other as they separate. Because when they're together, you know, they're in the same field. So they're going to mimic each other. When you start to separate them, not only are they still affected by that magnetic field that's resonating out from each one of them, but they're still more likely to do what either one of them were doing because they were both in the field previously. They were magnetized in sync by that field. So when they start to separate, there's still a field around them that's expanding around both of them that is intertwined with each other to a certain distance apart. But not only that, they're still mirrors of each other. But if if things change on one, they're going to change on the other. As long as they're still within the same field, they could be pretty far apart and still be in the same field. We're all immersed in a magnetic field that we can't detect. Obviously, all the matter that is energy right now, the field that we're immersed in, it's theoretical, but it's got to be there. They're in it too. So when they separate, their magnetic fields, flux lines are still around each other as they separate. So you couldn't suggest that they could separate to a distance, unimaginable distance, and still do the same thing, because after they get far enough apart, they're going to be affected by their localized area, and they're going to start acting in accordance with their new localized area, the effects that that localized area has on them. But in the experiments that we do that are limited, we're going to see that at close range because we're not going to be able to detect it at far enough range away. The theories about the rabbit in the box and all that is just made up. What we're seeing is two particles that just separated. They're still affected by each other. They're still tied together, just like if you had two magnets together and you pulled them apart, their magnetic field lines are still entangled. And you could get them pretty far apart, and those field lines are still together. So in theory, the same thing could be happening when you separate two particles. They're not only wanting to be mirrors of each other because they were magnetically entwined, but they're also affected by each other because the fields expand out beyond each other, and they're still intertwining each other into the same field. Plus, they're in this field that we all live in, so they can go pretty far probably. But nobody has ever proven that they could go at distance and still do the same thing, like communication. That hasn't been proven. It's just made up.